This is section 1.5, going back on rounding and estimating. So we're going to learn officially how to round and use that to help us estimate. So you can round to any place values, it doesn't matter, but there are very specific rules for rounding. So you have to follow very carefully the steps for rounding. The first step is to underline the place value you're being asked to round to. I want you to physically underline that place value. So you underline the place value you're being asked to round to. From there, you only look at the digit to the immediate right of what you underlined. Immediately to the right, the very next digit to the immediate right of what you just underlined. So we're going to physically underline the place value. Then we're going to look at a digit immediately to the right of what we underlined. From there, if the digit at the right is 5 or more, 5, 6, 7, 8, or 9, we're going to change the underlined digit to one value higher. If the digit from step 2 is 4 or less, we do not change the underlined digit. So we have a decision to make. We look to the immediate right of what we underlined. If it's 5 or more, we change something. If it's 4 or less, we do not change anything. From there, all the digits to the right of the underlined become 0. So it's a very specific way to round. And I know when I first learned it, I wasn't following these exact rules, and I got myself very lost. So you want to underline the place value you're being asked to round to, look immediately to the right of that digit, make a decision, and everything else changes to 0. So we're going to follow these 4 steps very precisely and make sure that we can round correctly. So let's start with these. Round to the nearest 100. So we're going to underline the hundreds place, which is the 7 in this case. We're going to look immediately to the right of that digit. We ignore the 9. So that the digit immediately to the right of what we underlined is 4. That tells us we do not change the underlined digit. So the 7 stays as 7. I'm going to put a squiggly equal sign. The 7 stays as 7, and the other digits become 0. So this squiggly equal sign is the symbol for approximate. So when you round, you're approximating. 749 is approximately 700 if we're rounding to the nearest 100. So again, we underline the digit, we look to the right, we make a decision. Once we've made that decision, all the digits to the right of what we underlined become 0. Let's do it again. We're going to underline the hundreds place, which is the 4. Look immediately to the right, which is a 1. The 1 is 4 or less, so we do not change the underlined digit. The 2 at the front stays a 2. The 4 stays a 4. The last 2 digits become 0. Rounding to the nearest 100. The next number, we underline the hundreds place, which is a 0. We look immediately to the right, which is a 7. 7 is 5 or more, so we change the underlined digit to one value higher. So this one, the 7 and the 3 will stay. The 0 will become a 1, and the last 2 digits will be zeros. So 73,100. And finally, we underline the hundreds place, the 3. We look immediately to the right, which is a 2. The 2 tells us to do not change the underlined digit. Anything before the underlined digit stays. 5, 4, 6. This means that the 3 stays a 3, and those last 2 places become zeros. So it's a very, very specific process, and take your time. Don't guess. Don't make up your own rules for rounding. Follow these 4 steps precisely. Underlining is so crucial. That really, really helps you focus in and make sure that you'll get the answer exactly correct. This is not a difficult process, but it's very particular. Now let's practice rounding to the nearest thousand. So we'll underline the thousands place, look immediately to the right. That tells us to not change the value, so it'll be 6, 0, 0, 0. Everything to the right becomes 0. The next one, we underline the thousands place. We look immediately to the right. Those 9s don't mean anything. We look at the 4. The 4 tells us to not change the 0, so it's 4, 0, comma, 0, 0, 0. Here we underline the thousands place, which is a 9. We look immediately to the right, which is a 5. The 5 tells us to change the underlined digit to one value higher. Now this is a little trickier. The 9 becomes a 10, which makes this 89 change to a 90 and then 0, 0, 0. That is the only time the number in front of what you underlined will change, is if you have to change a 9 to a 10. Then the number in front of it will change. Otherwise it will not. Last one, we underline the thousands place. Look immediately to the right. The 8 tells us to change the underlined digit to one value higher. So that will be 5, 9, 0, 0, 0. So take your time on these, follow the steps so that you don't miss these problems. They're very simple, but they require very careful attention. Alright, one more set. This time we're going to round to the nearest 10. So the tens place is the second place. We look to the right. The 2 tells us not to change. So it'll be 2, 4, 1, 0. 2, 4, 1, 0. Tens place is the 7. We look to the right. That's a 7. So it'll be 7, 3, 0. This 7 will become an 8, and then 0. 7, 3, 0, 8, 0. Again, the tens place is a 9. The one next to it is a 9. That tells us to change the 9 to a 10. So it's going to become 4, 0, 5, 0, 0. So again, that's the only time you'll change a different number other than what you underlined, is if the 9 needs to become a 10. One more time, we're rounding to the nearest 10. We look to the right. The 5 tells us to change the 2. So it'll be 5, 4, 6, 3. The 2 will become a 3, and then 0. So very, very carefully rounding. Alright, and the book talks about something called front-end rounding, which is a little different. I hadn't heard of that before. However, we do this all the time. We use front-end rounding all the time. So we're going to round to the leftmost place value, whichever one it is that's furthest to the left. And the way I think about this, the example the book uses makes it really clear. If you were shopping for furniture and you saw a couch priced at $988, what number would be in your head? I think most of us would say 1,000. So 988 makes us want to round up to 1,000. If you saw a chair priced at $209, our brain's just going to round that off to 200. We're doing front-end rounding. We're looking at the first digit to the left, the leftmost digit, and kind of using the number to the right of it to round off. So that 9 is becoming a 10. Again, we're looking at the first place value we can see, the leftmost one, looking immediately to the right of it, just by nature, and rounding from there. So, if I was walking around the furniture store and saw these two prices, I would round them off to 1,000 and 200. So how could you estimate a total cost for both items? We would just add our two rounded numbers together and we would estimate $1,200. Plus tax and all that other fun stuff. But if we were just kind of walking around trying to keep numbers in our head, that would be the easiest way to do that. So we're going to use that idea of front-end rounding to round these operations. We don't have a calculator and we don't need exact answers. We're just going to round off and get approximations. So we're going to use front end rounding. The 8 is what we round to. The 2 makes that round to 800 minus, there's our place, 9 rounds it to 300. 800 minus 300 is 500. So this is approximately 500, about 500. The next one, we look at the 3. The 0 tells us to not change the 3, so it's 3,000. Plus, we round with the 8. That rounds to 7,000. 3,000 plus 7,000 is 10,000. So this is approximately 10,000. So we're going to round off, add the rounded numbers together, which makes it way easier, and then that'll be our approximated answer. And the last one, 52 rounds off to 50. I'm going to do keep, change, so it's going to become plus 89 rounds to 90, minus, again, keep, change, so that'll be plus negative 139, so that would round to 100. 50 plus 90, 140, plus negative 100, which is 40. So this is approximately 40. So what this does is make our lives a lot easier and gives us an approximate answer. Not exact, but an approximate estimated answer using front end rounding. And that is it for rounding. We're going to move on now to order of operations. We'll start with exponents, and then we'll get into order of operations. This is section 1.8. This will be the longest section of this chapter. We're going to break it into 2 parts. I'll do exponents first, and then we'll pause, and then we'll get into order of operations. All right, so exponents are a way of doing what I call repeated multiplication. Exponents are those small little numbers that are kind of raised a little higher, superscript, from the other number. So 2 and then up to this little 1 means 2 times itself 1 time, which is just 2. 2 to the second power, which you'll also hear called 2 squared, is 2 times 2, which is 4. 2 to the third power is 2 times 2 times 2. Well, 2 times 2 is 4, times 2 again is 8. So 2 times 2 is 4, times 2 again is where we get 8. 2 to the fourth power is 2 times 2 times 2 times 2. I just figured out that 2 to the third power is 8, so these 3's will be 8. Times 2 again makes 16. And 2 to the fifth power is 2 times 2 times 2 times 2 times 2. I've already done it. To the fourth power is 16, so I just multiply by 2 again, and that gives me 32. So we're going to use that idea. So we're going to compress this using exponents. It's 3 times 3 times 3 times 3, which is 3 to the fourth power. 4 is just 4 to the first power. So if you don't see a power, it's being raised to the fourth power. Here we have 1, 2, 3, 4, 5, 6. So this is 7 to the sixth power. All right. We're going to use that idea to do a couple problems. This is 2 to the third power, which we figured out is 8. So this is 8. This is negative 3 to the second power. So this is negative 3 times negative 3, which is positive 9. So we have positive 8 times positive 9, which is positive 72. And over here we have 3 to the third power, 3 times 3 times 3. Well, I know 3 times 3 is 9, and 9 times 3 is 27. And then negative 4 to the second power is negative 4 times negative 4. This gets a little messy, which is positive 16. So I have 27 times 16, and we do not have a calculator, so we're going to have to multiply this out by hand. 7 times 6 is 42. 42. 6 times 2 is 12, plus 4 more is 16. And then remember, we put a 0 for a placeholder. 1 times 7 is 7, and 2 times 1 is 2. And then we add these together. Now, you might have learned how to multiply like that a little differently, but you should be able to still get to the answer. 2, and then this is 13, 4. So big number on that one. Sometimes these numbers will get a little big, and you'll just have to work them out by hand. I'm going to pause there, and then I will record for order of operations.